Hello, everyone. Next up, we have Daniel Svonava, co-founder of Superlinked. He will be talking about how to take control of your RAG results. Over to you.
Thank you so much. All right. Do come forward so that I can see you and I can see how confused you all look and, adjust. That's really helpful. This is kind of a niche topic on one side, but sort of everybody's problem on the other. So good to see that somebody cares about quality. So let's get this going. I will start with a statistic just to calibrate the size of our problem here. This was the Algolia CTO last year. Algolia e-commerce search, they ran 120 billion queries per month. And they, in their query logs, they have seen the number of keywords double per query, right? After ChatGPT launched. So people around the internet are trained to ask more complicated questions. They expect better answers from our systems. So if you build any kind of search, information retrieval system, anything with the search box on it, you have a problem now, right? How do we service these more complex questions? And the talk is about RAG, I guess. But my first question that you should be asking yourself is, should I be actually doing RAG, right? Is that the highest leverage way to help my user, right? And what is the sequence of thoughts that leads you to a place that, actually, let's do RAG? So I'll actually touch on that a little bit as well, because it actually then puts us in the right context for getting it right? Otherwise, if it's not the most beneficial thing you can be doing for your users, don't do RAG. Simple tip, right? Okay, so that means you have to understand what the user is doing with your stuff, right? You have to understand the journey end to end. Okay, in e-commerce, maybe people are trying to get to know your brand and eventually browse your catalog, and maybe they sign in, maybe you make them to make an account, and then maybe they come back, and at some point in the journey, a shopping assistant is the best solution, and then you find yourself building a retrieval augmented generation system. But it has to be from the point of view of understanding the journey and how your solution actually unlocks value within it, right? And then you have other, there is support enablement. Again, don't focus on some sort of lookup for the sales rep or support rep. Think about the whole process of what it takes to support a customer and actually understand what's going on in there. And my point with these couple slides is to just make you aware that the end-to-end journey is complicated, right? It has many touch points. It should be somewhat consistent. And again, is RAG the thing that will help this, that will fix your problems, right? And the takeaway from those slides is work with somebody who understands the user journey, right? Who understands what the user is going through. And as data scientists, we are often scared of the PM, right? Because PM has ideas. They are hard to express as a loss function. How do we train a model that does things that maybe are actually the opposite of each other, right? So we are scared of these folks sometimes. But if you want your system to be effective, you have to make friends with them, right? So that's my first tip of how to get RAG to actually work, is make a friend out of your product manager. Okay, and then when you find the bridge to talk about your users, your use case, your actual problem, try to, we have all heard about test-driven development, right? We write the unit test first, and then we develop software that passes the test. With ML-powered systems, the equivalent is like eval-driven development, right? We think about the eval, we think about, okay, how do we describe the problem? How do we describe the kinds of things the machine should respond with? And then design a system that does that, right? So make an eval first, and then build a system. It's almost like a specification, right? And your product manager can, they write product specifications all day, right? so they can help you with the eval. And now that's the ROI on making friends out of them. Okay, so what does eval mean? Like, how should we think about evaluation of RAG? Well, you have kind of two components, right? There will be some queries. These are the demands of the user or client system, right? This is what they want, questions they want to answer, some sort of retrieval objective they have, and so on. And you should think about this first. And people get this wrong. They start with step 2. It's a step 2, right? Start with step 1, which is, okay, what's the thing that represents the problem? And that's the query, right? And then, once you know, okay, here are the kinds of things I want to answer for my users or for the client system, then think about, okay, what data do I need to bring together to answer these things, right? It's important ordering of those 2 steps. It's only 2 steps. It's not too hard. And so, okay, where do these things come from, right? Queries. Okay, these things are ordered, right? From, I think, easiest to get and most valuable to the less valuable, right? And so let's say you are building a rack system and your product already has search. Maybe go look at the query logs for that search system to figure out what people are typing into your search box, right? And maybe you will find out that for certain kinds of queries, your current search system is actually, let's say returning no results whatsoever, right? And then that's like a great place to start thinking about your rack system, because if you do anything half reasonable for those queries is net gain, right? So it's easy to justify. Okay, query logs. First place to go look. And then, if you are shy and you don't want to jump straight to talking to people, you can mine other sources of information, right? Like, for example, if it's a support use case, go look at the kinds of support questions people have in other media, right? Slack, and so on. If your company already has a bunch of people that you are trying to augment, right? You are trying to build RAG for sales or support folks, figure out how those people are trained, right? Because they'll have a bunch of examples there of the kinds of things they have to handle. And again, that could be a part of your query eval set, right? And then the difficult stuff starts, which is, okay, now we have to actually talk to somebody, right? And so ideally, it's the people who will type those queries into the system that you eventually hope building. And after the product manager, who you think about as a kind of aggregator of the user problems, the sort of next hop is the actual users, right? And you'll have to do some aggregation yourself. You have to chat with a few of these people. But then you'll have the data from the source. So figuring out user interviews, very important. And then, once you start to put something together, maybe you have a few queries already, show that to people and ask feedback, like, hey, am I missing something? Maybe you build like a super simple system and see what they will type into it. It's always the more real you make it, the more real data you'll get, right? If you ask people, hey, what would you search in this rack system? They'll make up something that they'll never type into the actual system afterwards, right? Because it's a different state of mind when they actually have the problem versus when, somebody from their company is annoying them with some questions. Very, very different state of mind. So create a realistic situation and extract realistic queries. And then eventually, okay, let's say you gathered some queries, you need more for robust evaluation. Okay, go make some synthetic data, kind of expand the set of queries, valid use case for a language model, for example. Okay, so this is our problem specification. We have our universe of queries. These are the things we want to answer, right? And once you have that, then maybe you cluster them like, okay, which kinds of queries do we have, right? There will be some patterns. You'll sort of organize that somehow. And then it's time to start thinking about, okay, where are the answers to these things? And that's in the data. And again, there is the ordering here, right? Start with data that already has some kind of structure to it. If you have a database table that, let's say, has a string column and a couple of other properties about your customers, about your support tickets, whatever it is, start there, right? Don't go extracting from some super messy PDFs as a step 1, right? That's make step 1 easy, right? Start with something that makes half sense by itself, right? And then when it's sort of not enough data in the cleanest place you have, which is your relational database. Why is it the cleanest? Because your business literally runs on it. It runs on the relational database. It's the cleanest thing you have, because if you don't, your production is down, right? So there is big motivation for that data to be good, right? Okay, so we are using that first. We exhausted that data. Now we go to the second messier place, right? And that's a data warehouse. It's still kind of structured. It's still objects, right? But it's, there is like history to it, and the schema evolves, and data warehouse is messier than your relational database. So, but it's still not just a document that you have to OCR, right? And so, okay, data warehouse second. And then, okay, we exhaust that, and then, okay, fine. Everybody's doing chat with PDF first. Why start there? Like, your company has all kinds of other data that is like way more accessible, easier to work with. But at some point, you will have to deal with the PDFs, because the language models help us there a lot, right? So we can extract value there, but please don't start there. And then next one down, like binary data, right? Videos, audio, all the other stuff that we now have pre-trained models to do something with. It's probably a good second, sort of fourth step after that. And eventually, let's say you don't have enough data, generate some, right? To have more robust evaluation, to fill in the kinds of data that, let's say you have too few examples of for the given class, make up some more to balance out your evaluation set. Okay, so we have gathered our queries. Those are the problems. We have built a data set that's ideally as clean as possible, because we use clean sources. And the last problem we have is, okay, how do we actually evaluate the thing, right? What kind of metrics should we use? And this is a lightning talk, and I'm not going to give you a download of 15 different information retrieval metrics. You can Google those yourself. But in general, I think this is so RAGAS is a framework for evaluating RAG performance, and there are kind of like 4 metric categories that I think are interesting. You have kind of precision recall for the retrieval part, and you have sort of like truth and relevance for the generation, right? Because the model is the model that does the generation of the answer given the retrieved results can inject more noise, right? So you want to kind of track both okay, is this still true given what was retrieved? Is it, isn't there some sort of made up thing being injected in the meantime? And how relevant is the answer to the actual question? So I think this is a good framework, and you should sort of make sure you cover your bases. But at the end of the day, we all want to get promoted, right? That's kind of the goal of the job. And there is like one metric that works really well for getting promoted, and it's my favorite acronym, and it's USD, right? Hopefully, you find a way eventually to frame your RAG project as something that either makes the company more money or saves the company money. I mean, that's literally the 2 only options you have, and this is the metric that you should use to track it, and that's the metric that actually matters in the end, right? Unless you work for like a non-profit or something, where it probably matters still. So that's my recommendation, is to, okay, think about frameworks, think about metrics that are proxies for this, leading indicators, but never lose sight of this, right? And it's very easy for us technical people to just live in a made-up world of some other metrics, and then your promotion package is like, okay, we improved this by 5%, recall, whatever. Who cares? Right? Who cares? Dollars. Okay. All right. So that's our sort of search space for a solution for any information retrieval system, but also RAG. And in the RAG world, we have these methods focus more on the retrieval, on the R of RAG. These are some levers that you have to actually then start iterating, right? You have established your queries, your metrics, your data. You have built relationships with the right people in the organization, and these are some of the things you can do to then iterate towards the actual quality. And I have like definitely not enough time to go into any detail here, right? One thing I'll mention is that they are all worth trying and exploring, but at the end of the day, you'll try filtering, you'll try re-ranking, you'll discover their limitations, right? If you interpret, hey, I want popular t-shirt, if you interpret popular as a filter, there is a limit to how useful that can be, right? Because what it really is a signal. It's the intent of the query. And in sort of real world systems, you have these kinds of intents that you can't really re-rank on, you can't really filter on, and eventually you will have to build a system that somehow has this kind of structure, right? You have some kind of data, you do your rack over, you'll have to figure out how to take in each of those entities, and for each entity, make a vector that encodes everything you know about that entity, all the signals, right? Numerical signals, the content features, behavioral data. You need a vector that encodes everything you know about the transaction, the piece of news, the chunk of the knowledge base on one side. And you have your complicated queries, right? We have twice the number of keywords per query. Queries are complicated. Yeah, we can interpret some of these as filters and re-ranking rules and so on. But eventually, if you actually want to solve the problem, you have to, again, find a way to take something like that and make a vector that encodes all of that. And then we have the vector database stuff, in the storage layer that if we can succeed in the encoding problem on both sides, then the database can help us match the two together because you do cosine similarity and everything is great, right? But this only works if you actually encode everything on both sides into the actual vector, right? There's a way around that temporarily, but eventually that's fundamentally the only way to do it properly. And you can't really see that picture, but I have like 2 minutes or a minute to tell you about what actually we do at Superlinked. We have an open source framework, Apache 2, free to use. I'll have a GitHub QR code at the end. And what it helps you do is those two encode arrows, right? We help turn complex data into vectors. And that has to do with helping you assemble multiple encoders, right? Your complex data, let's say your news article has a timestamp of when it was published and popularity signals and which users click on it. And maybe there is an image in the news and there is text and all of this stuff, right? We have a framework that helps you bring in the right encoders for all those different signals and combine their outputs to make a vector that encodes everything you know about the news article across all the signals, right? So like this arrow and that arrow is what Superlink does. And then we work with vector databases for the indexing, right? So we are basically like a compute layer on top of a vector database. And here is just a representation of when you have such complex data, some numerical timestamp features and text, and you turn them all into one big string, and encode that string with the language model to get the vector that encodes everything, you get something that doesn't represent the information properly. If you stringify a number and encode it with the language model, it's super noisy and very inefficient to do that, right? And we have direct ways to encode, for example, numerical features alongside text and so on. And so our vectors are better, and somehow this picture shows it. Okay, 2 resources that we have online. One is called VectorHub, superlink.com/VectorHub. We have 29 in-depth articles of building vector-powered software. And then if you go vdbs.superlink.com or that long link, we have a crowdsourced comparison of vector databases. There is 40 databases on there compared across 40 different features. If you are choosing a vector database, then talking to me might be a good idea. I have spent a lot of time with many of them. And that's it. Good luck with your RAG systems. May you get some control over what they respond with to your users. And yeah, like hopefully this time next year, there is more of this stuff in production and you all got promoted because you launched it. Thank you.